So, here we will learn something called upwelling, welling up. What does it mean? Basically, in the ocean there are places where the cold water from below the surface is brought to the surface, and we will see later on that when you look at the distribution of nutrients, there are more nutrients below the surface. So, every time there is upwelling and cold water coming, that those nutrients are brought up, which means you have production. Nutrients are like fertilizer, and near the surface there is sunlight. So, you will have chlorophyll blooms, or plants in the oceans will grow, which means you will have fish growing and so on. So, how exactly is upwelling created? So, we learned about Coriolis, where we said that the Coriolis effect pushes things to the right of the direction of motion in the northern hemisphere and to the left of the direction of motion in the southern hemisphere, right. And if you remember Coriolis, it starts with 0 at the equator and keeps increasing to the surface, which means if you are going on the equator, you are not moved to the left or right, right. But as soon as you step off the equator, you are being moved to the right in the northern hemisphere and to the left in the southern hemisphere. This creates some very interesting processes in the ocean, one of which is the upwelling. So, here we are looking at a section of the ocean where we have the equator in the middle. This is the direction towards the north, and this is the direction towards the south. Okay? And I am showing here the trade winds in a big green arrow, and we will learn about trade winds in another module, but basically they are winds coming from the southeast and going towards the northwest. Okay? So, basically this wind, as it blows, it is trying to push the water towards the west and north, right. But because the equator changes the Coriolis effect on either side, the water cannot really cross the equator. So, to the south of the equator, as the water is being pushed this way, it will be pushed to the left. To the north of the equator, as the water is being pushed to the west, it will be pushed to the right. What does this mean? So, you are basically pushing water away from the equator. This is like Moses parting the water, right. If you move water away from the equator, that means there has to be some water to replace this water that is being pushed away. That means the water that is below is being brought up. So, the winds are moving water towards the west and towards the poles, left in the southern hemisphere, right in the northern hemisphere. So, you are moving water away from the equator, colder water is coming up. Okay? This is essentially called upwelling. What does it do? It turns out that this upwelling is very important for everything we will learn about, as I said, where the fish are, where the chlorophyll is, and also where the cold temperatures are, because the temperature below the surface is colder, it is not getting direct sun energy. So, it is colder water, and this is also important for El Nino. So, we will see here the distribution of sea surface temperatures. Okay? So, the trade winds are basically blowing from the northeast and the southeast this way. So, this water that is being pushed to the west is being piled up here and warmed, creating very warm temperatures near Australia, New Guinea, Indonesia and so on, and also in the Indian Ocean. But the Indian Ocean is special because of the monsoons, which we will learn separately. But let us go back to the upwelling. So, as we said, as the waters are being pushed towards the west by the trade winds, the water is being moved away from the equator in both hemispheres, and you can see that the cold temperatures here are basically because the cold subsurface waters are being brought up. How cold is it? The temperature here is almost 30-31 degrees centigrade. The temperature here, if you look at the scale, it is about 20-21 degrees centigrade. So, there is a change of temperature going from Galapagos, for example, to New Guinea of almost 8 to 10 degrees centigrade. This gradient will be very important when we look at things like El Nino, because the cold temperatures create high pressure in the atmosphere, warm temperatures warm the air, air rises and causes low pressures here. So, high pressure and low pressure can create winds and then that can lead to other things like El Nino and so on. So, the upwelling, it turns out, is very important for a lot of things like phytoplankton production, fish production, cold temperature production, and El Nino and so on. We will come back to El Nino in another module. There are some interesting problems associated with this module that you can work on.